Over a fire, we are going to transmit heat and we are going to put on top 2 ice cubes so that we can see how fast one ice cube melts and how the other one practically doesn't get affected at all, and it remains due to heat not trespassing the film that we are going to be making with cork. We are talking approximately of about 3 millimeters of cork. That's what we're using now. Let's start. We place the board more or less in the middle, and now we are going to take 2 ice cubes and let's wait and see. Pay attention.
Fijaros cómo es prácticamente inmediato.
Pay attention how it's almost immediate. The cube that's out of the cork has almost melted.
Derretido. Fijaros lo que pasa.
Now look at what happens if I pour water on the same line where the cube is. As you can see, there is almost no water, just as we left it at start. What we are demonstrating here is that the side where the tin has been exposed at a temperature of about 120 to 130 degrees has caused the ice cube to melt immediately, while on the other side, where the cork is, it doesn't allow the temperature through and the ice cube doesn't melt, or it would do, but at a much lower pace. If we transform this into a wall that's exposed considerably to strong sunshine, imagine the sun doesn't have the ability to reach 130 or 140 degrees at all. So it would be much more efficient, the thermal transmittance of heat that there would be over a surface that is not exposed to the cork. Okay then, now in this test we are going to demonstrate how the insulation system ceramical stream works, which is a reflexive insulation system based on aerospace technology. It is what they used to paint spaceships in the 80s. And this technology's patents were published and we accessed one of the licenses and we brought it to Spain. And our product is based on this aerospace technology. Here we have, to scale, a set of industrial buildings where we have put an insulation on the metal, and on the other one we've left it as it is, and we are going to see what happens with the temperature through infrared. Infrared works as if it had the sun shining over, and the temperature that is exposed to. Let's proceed and see how it works. What we have here is a reflexive insulation. What happens with reflexive insulation is that the sun doesn't affect it. It doesn't let at any time the building to heat up. But then, as well as an insulation against heat, we would also need a good insulation for winter, because if we had no sun heating on the reflexive insulator, we would encounter a problem. Why? Because if there was no sunshine, that we'd have left is an intense cold feeling, especially inside, which will result in condensation indoors. That's why insulators have to be able to work for both heat and cold. The temperature here is 169 degrees. In fact, I'm not sure if you can appreciate the noise that it's making. Look at the cube. At the temperature it's exposed to, watch it melt, while if we place the other ice cube on the insulated one, it does nothing at all.
Vamos a demostrar como si fuera una calefacción, ¿vale? Dentro.
Now we are going to demonstrate as if we had heating inside. We are using 2 60-watt bulbs inside each tin. Those bulbs are simulating indoor heating. And when we switch them on, we will see that where there is no cork, there will be a heat loss. While in the other tin that has a 1.5 millimeter film of cork, all the heat will remain inside. And on the iron, we are going to do the same. The iron is a material that heats up very rapidly. We are going to see on the titanium how it heats up a lot, while on the cork we are going to see through a thermal camera how it spreads the heat evenly all over the surface. We proceed to plug in, making sure that it's working. And now what we are going to do is to start building up heat slowly and steady. We have 119 degrees on the iron side,
donde no tenemos puesto el aislamiento,
where there isn't any
medida que
insulation,
vamos bajando,
and as we take it down,
va
it turns
pasando a frío,
colder.
¿veis?
See?
Ya estamos en
It's
el
on the
corcho,
cork, and the
y
temperature
tenemos ahora
already
mismo
has gone
a
down to
57
57
grados. Si
degrees.
acercamos, ¿veis? Esta lata
If we
está
get close to this tin,
en
it is
torno
at a
30
temperature
grados,
of about
¿vale?
30 degrees.
¿Veis?
See the
Los
red
puntos
dots?
rojos
They're
es el
pointing
calor,
out
está
the
totalmente
heat
disipado,
spots.
está frío,
It is
no
not
repartido
evenly
igual.
spread.
27, 22,
Now look at what
29,
happens when we
fijaros lo
put
que
the
pasa
camera on this
cuando
one.
nos venimos a esta.
The thermostat starts rising because all of the temperature stays within the tin and well distributed all over the space. See? 44,
44,
45,
27,
47. We are nearly 15 degrees of temperature. It's all red all around, evenly spread.
por todos lados. Como podéis ver, en
As
la
you
lata
can
donde
see,
no tiene
if the
corcho,
bulb was central heating in the non-insulated tin, be it heat or cold exposure, we would only be losing energy, while on the insulated tin, whether it's exposed to heat or cold, it remains within, and that's where we get our energy saving from.
dentro de la,
We arrive to a country home and it's very cold. When we arrive on Friday, it's very cold inside, so we light a fire. But we'd have to keep adding wood logs all day long, and it still feels cold. We wake up on Saturday, add more logs, but it still feels cold. And on Sunday, when we are returning back home, is when it starts to feel right. Why? Because we've had to heat up all the space inside the property, and until walls and ceilings haven't heated up, we haven't started to feel comfort. But not on this one. What we have done here is that all the heat stays in. We only had to modify one AC room.
En esta prueba ahora lo que vamos a ver es cómo
Here we are demonstrating how on a metal, in this case copper, we are going to expose it to heat with a blowtorch, and we will see how we won't feel the temperature on the other end. We will not burn our hand or feel any heat on the pipe, which is the tricky part.
tubo, que es lo más
An insulation that does not burn your hand is easily achievable. What's difficult is to have one that you could touch and not feel the heat, as we are about to see.
Aquí podéis ver cómo se va a someter. Igual que yo lo puedo coger aquí,
I can grab it and not burn, that's the easy part. But watch now if I touch the other end. I'm not burning. This is because the insulation doesn't allow
que
it.
tengamos lo que es la resistencia, tenemos una resistencia térmica y no deja que haya una conducción. Todo lo que son conductos de calefacción, conductos de biogás, por vapor, todo lo que son altos hornos, estamos haciendo ahora.
This could be a conduct of heating, naval piping, which we're currently testing on. We are changing the rules of insulation since now we won't need heavy materials to contain the temperature.
Tenemos aplicadas 350 micras.
And we have applied 350 micrograms on a Segeta tool. As you can see, it's minimum weight, and we are going to apply the same function. We are applying heat, and in no moment at all we burn our hands.
Vais a ver cómo se va poniendo.
This is a thin metal that heats up very fast, and as you can see, it's turning red.
Absolutamente.
I remind you that on the other side, there isn't absolutely anything. Look, it's not letting it get hot because the part where the ceramic is acts as a barrier and doesn't permit it to heat up.
Imaginaros, por ejemplo, lo que pueda ser una puerta
This
metálica.
could be applied to a metallic door, or a home, or a big gate of an industrial building. When it's extremely hot or cold, all that temperature is controllable, and it keeps a pleasant temperature inside. Applying 300 or 400 micrograms of this material, we would achieve a total barrier against extreme temperature.